All right. A little disorganized since I had the thing listed for March 31st instead of March 30th. So I hope people are coming in as expected. Well, we have a few. Hi everyone. It said scheduled to start at 2:30 on the 31st because I guess I hit the schedule at the wrong time. Well, anyway, hi everyone, and welcome to today's episode of the Tom's Hardware Podcast for March 30th, 2021. As always, I'm Avram Pilch, Tom's Hardware Editor-in-Chief, and I'm joined by Raspberry Pi expert Ash Puckett and Associate Editor Les Pounder, and our special guest today is Isaac, my son, who's been on the show once before, to talk about some really cool game programming. But while folks still filter in, and before we get started with the meat of the show, what have you guys been working on this week, Ash? What have you been playing with?
I have been playing around with trying to create an audio visualizer, which is something that you don't see too much with music these days. But, you know, when we were computing back in the 2000s and 90s, when you would play a song, you would usually have something either on your computer or your stereo where the LEDs would flash and flicker whenever the sound would come through. It would move to the music that's coming through. So I wanted to create something like that on the matrix behind me. And the idea was it could either play in accordance to a song that you put through, or it could respond to live input from a microphone. And to do that required a server, which I'm having trouble getting to work right now. But I have a quick video that I can show you what it looks like whenever it is working. So here's a few pictures of what one looks like that I was trying to set up. This is called Audio Visualizer for Raspberry Pi, created by Thomas Coe. And here's a video of a different one that somebody else made, and you can kind of get an idea of how it works. As the audio spikes, it goes up higher, and that's what I was trying to create. I'm sorry that I couldn't get it to work in real time for us today. I'm sorry, I tried to show it to you and I didn't even show it to you. That's what it's supposed to look like. Now can you guys see it?
Yep.
Okay, good deal. Cool. I'm sure a lot of you know what this looks like, but I'm not sure if Isaac has seen too many audio visualizers whenever he listens to music. So,
well, I have seen them in Audio Maker. Sometimes they show that for your audio.
It makes it a little cooler, doesn't it? You can see your music instead of just hearing it.
Yeah, sometimes when I use Audacity to record stuff, it shows that, but not real time. It just shows what the sound would look like on that.
Yeah, it's the same principle. That's really cool, isn't it?
Yeah, I mean, that's how you know that your stuff is working, right? That might be actually a good thing for me to use on the LED matrix that's behind me, which keeps saying the PiCast, when I could make it do something more interesting. So, speaking of things that are interesting, wanted to talk. Well, first of all, Les, what have you been working on this week?
This week I've been working on something really cool. It's an ArduCam camera for the Raspberry Pi Pico. So you can do video on the Pico. And this is quite interesting because you don't normally think of the Raspberry Pi Pico as a video machine. Yes, it can do DVI output. It can do VGA output. We don't really think of it as a video capture device. But this camera is pretty cool. I'm going to go to an overhead camera so you can see what it is. There it is. It's an OV2640 camera, 2 megapixel. So it's not going to take fantastic photographs, but that's not the point of it. It's there for machine learning. So TensorFlow for microcontrollers. So,
I just don't know how the microcontrollers are powerful enough.
It is just. I mean, the image is really small, Isaac. It's only 320 by 320 pixels, which is tiny compared to photographs you take with your normal camera.
And MakeCode, you draw it even smaller, 16 by 16.
You can, yeah.
Yes, we'll talk about that. We'll talk about that in a second. So that's really cool because nobody would expect that you could actually do image recognition on something so low powered as a Pico.
Yeah. So right now it's actually doing image recognition to look for humans. So it produces a percentage to say, is that person a human? Is it an object? So I've tested it on myself, and I can show you now.
Yeah, why don't you demonstrate it now?
Yeah, here it is. So the camera is currently looking up at my lights. I'm going to tilt it round to face me.
It is questionably human, Les.
It's questionably. When it looks at me, it'd be questionable. Here we go. So I'm actually using a vice to hold this in place. I've got to be careful not to over tighten it. It could be a very expensive mistake.
You're mostly human.
Mostly human. It's if I'm really still. This is great for video. Being really still. It goes up. I'm mostly, partially. I've had it to 94%, so it thinks I'm human. So this is live video. This is coming out of the Pico via the UART connection to a USB device plugged into my USB reader, CP2102 for all the fans out there. And it's showing live video through an application called Processing. Now, Processing, you can see on the screen here, has a very similar syntax to the Arduino IDE. In fact, it's very, very similar, because I've got it wrong quite a few times today writing some code for it. And this is the processing application's made for artists to do visual art with code, along the same lines as the Arduino IDE was created for artists to create electronic art. Similar premise. And right now, this is streaming data from the Pico, from the camera to the Pico, down the USB, and it's checking to see if the image that is on the screen is human or not. So if I put something up there like my stand-in, I'll just grab my co-worker from the stand here. There is Spike, the gremlin. He doesn't like the bright lights very often. He's probably got a higher, 55%. He's more human than me. But it can detect a human being's face, and it can work with it to use it as an input. So we can program this Pico now to react, to do something with a motor, a servo, send a message over the internet using MQTT or something like that, and have it perform some acts based on the fact that it has seen a human face. But we can also train it, because it's TensorFlow, to recognize other objects. So you may have seen last year we had the Braincraft hat from Adafruit. We can train that hat to see an apple or an orange or a banana, and it can just work with that as an input, and it's really clever. Now, this is a kit that I'm reviewing for Tom's Hardware. It's about $40 for the kit, but this camera also works on every microcontroller and every microcomputer that you can think of. So Raspberry Pi, Arduino, ESP32. If it's got an SPI connection, an I2C, it'll work with it.
Have you had a chance to test it with any other boards yet?
Not yet. I was getting this demo working to make sure it was spot on.
Yeah, and it is. That's a really cool project.
I'm 52% human, which is good.
So what do you need? What if you just had the camera, could you make it work, or do you need, what else do you need besides the camera?
You need two pieces of software. So the Raspberry Pi Pico has some C code on it, which really just streams an image from the Pico via the UART connection to the USB peripheral. You need this helper program in processing to recognize the video stream and to do some calculations behind the scenes to actually do something with it. Other than that, it's just raw video data at a really low speed, a low FPS.
So does it require the USB connection to your computer in order to do the recognition, or is it happening on the Pico?
It's happening on the Pico. All that's going out to the UART on the computer is just the raw data of the video signal overlaid with the text that says human and then a percentage.
So if you had this, say, could you use this in combination with like the VGA, the Pimoroni VGA Explorer, as it's called, the VGA Explorer, the VGA output, where you could output this to a screen directly?
Possibly, yes. There is another version of this coming out called the Pico 4ML from ArduCam, and that has the camera and the screen built into the Pico, and it's the same size and pinout as a Pico, which is quite remarkable given how much tech you pack into the board.
So, what do you think someone would do could do as a practical project with this type of image recognition?
You could have projects such as security projects. for a demonstration purposes. We probably won't use it for full stop security. But recognizing a face and opening a door, for example, or something in the home to recognize if a child has gotten out of the bedroom and is in a room they shouldn't be, that sort of thing. You could use it for robotics as well, for detection. You could have the robot follow a ball, so you could see the ball bouncing in the camera and follow that object along.
What would you use it for, Ash?
Probably something involving the cats, because they're always going places they don't need to be. And wouldn't it be fun if you could deter them with something gentle, but automated for the Raspberry Pi?
like spray water or something.
Or maybe shake something that makes a loud sound with servos, like some plastic bags or something that rattles.
Isaac, if we had this set up, what would you if we had this ability, what would you use it for?
I would use it to make a robot.
What would it do in response when it sees stuff?
Well, it could, I guess, maybe be one that can follow a ball.
Right. Yeah, follow a ball. Now, can this get specific enough that it could recognize a particular face, or it has to just be any human?
That I don't know. I would make an assumption based on the amount of tech we've got here that it would be very general to just like a person or a dog or a cat. It couldn't really differentiate between male, female, beards, long hair, that sort of thing.
Yeah. So, but still pretty impressive for running on a board that has, that's operating at really low speeds with 2 cores and,
and it's $4.
And it's $4.
It was really impressive.
Yes. So speaking of $4, by the way, Isaac and I saw something cool tweeted the other day. Someone had taken a Pico and they had turned it into a Tiny or an Itsy Bitsy or something by literally hacking part of it off. They just took a saw or something and they cut, as long as it was, if I can have one here, I don't have one easily unplugged, but they kind of cut it off at this point below this, I guess, transistor here. And then it was shorter. They just only had 16 GPIO. So I guess that makes it a Tiny, right? So
and that made me laugh really hard.
Yes.
I can understand why, buddy.
So now, speaking of another Raspberry Pi thing, you can take your Raspberry Pi Zero and turn it into a really different kind of arcade machine. We've talked about emulation before, but this is something completely different where it's easy to program your own and for kids to program their own projects. So Isaac, tell us about this. What is MakeCode Arcade?
It's software for making your own games using block code, JavaScript, or Python.
So can you explain to us how a person will get started with MakeCode Arcade?
Okay, so to get started, it's really easy. You can just go to MakeCode. arcade.makecode.com, and then you can just scroll down till you find the tutorials, and then you can go through the tutorials that'll teach you how to code.
Great. Can you show us? So you have a program. Can you show it to us?
Okay. Let me just share my screen. Okay, share. So I can see.
Let me put this on here. Yep.
So I can see I have here my code for a game I made called Night Jump, where you have to fight all the skeletons with your sword and destroy them. But I can see it's a simple platform game. Just the goal is to destroy them with the sword. I can see I have this for attack and has an invisible target that then just shoots at it to destroy it. And I can see I have a lot of code.
You do? That looks like a lot of work. How long did it take you to put all that together?
Well, I did that actually yesterday. It took me a long time.
Wow. That's really cool.
So how do you get artwork into the game? How do you make the platform and the sprites?
So first of all, to make the sprite, you can just click on one of these, and then you can click on it to draw something. Like for example, over here, for example, I could draw a robot for a green robot, for example. If I wanted to make a game with a green robot, let's say, right, and then I do it like this, right?
Right.
Can you
so
import pictures too if you wanted to use artwork that somebody else made?
I don't know.
But there's also, if you don't want to draw yours, they have some assets you can use
Yeah,
that
you
come
can.
from MakeCode, right?
Yeah, you can click on gallery. You can select on, like for example, let's say with the duck. I could select one of the duck images. What I did for the night, I can click on all the images of the night. Let's say. Or
Right.
if I want an apple, I could select an apple.
Right. So they have a pretty good set of graphics that look like 8-bit graphics. 8-bit graphics here. And how is it working with the blocks?
Well, the thing is, the blocks are actually defined in JavaScript. That's how they work.
So if you wanted to code it in JavaScript, how would you do it?
You just click up here where it says JavaScript, and then you can code in JavaScript. If you want to click on Python, then you can click this, and then you can click on Python, and then they'll then if you want to put back the blocks, you can just select on blocks.
Have you been using Python or JavaScript at all?
Well, I'm really good at Python. I like to use MakeCode with blocks because sometimes the syntax gets really complicated because it's different from normal Python or JavaScript syntax a little bit.
I understand.
Yeah. So if you want to play your game, how do you preview it and what does it look like?
So I could click on over here to open up the simulator, and I can click on that to put full screen. And then I can click on these, or I can use my keys. My keys on my keyboard, I can see to play my game and preview it.
Right. So now what's interesting though is while you can do this completely on a PC or really anything, a Raspberry Pi, anything that has a browser or Chromebook even, what's cool is Adafruit has something that allows you to turn this into a standalone arcade machine where you can download the games and you can have a menu. So we want to show you that. So
yeah,
I'm going to come over here and demonstrate the physical part of it. So
okay, I'll come over.
all right. So here we. Let's see. So here we've got the. So here we've got the. Wait! Don't let your sister in. Okay, thanks. Anyway, so here we've got. What do we have here, Isaac?
We have the Pi hooked up to all these buttons with a remote.
So what do the different buttons do?
So this is the left button. This is the up button. There's the down, the right button. This is the exit button. There's the menu button, which is the pause button.
So there's 8. So there's 8.
There's the B button.
So overall, how many buttons are there?
8.
8. So let's show you what you can actually do with it. So here we have on our stream what the menu looks like, and hopefully, if the wires didn't come loose, you can see that.
Wait, right?
It seems to be a little bit on the frozen side for some reason. Let's start and restop it. Restart and restart it.
Not working. Let me try.
All right, wait. Okay, so let's try switching cameras just for a second to show folks. So this is what the menu looks like, and then if we go.
No, I think I have an idea.
I think what we do is change it. We'll change it to the mirror box, right? Can we do that? Let's see. Mirror box is the camera for this. Maybe not. Let's see. This might be a challenge. All right, or we can just do this.
No, it is working.
Oh, it is
Mirror
working? Okay.
Wait, it just turned off for no reason.
I got to tell you, we need a better video capture thing.
I think OBS is using it.
You think OBS is using it? All right. Well, let's do this the old
No. Let's do it the real way.
Okay. So, anyway.
No, it'll be better if you do the real way.
Do it
Close OBS.
I did close OBS.
It is open.
All right. Hold on. All right. We will close it and reopen it, but I think
No, don't open it.
don't open
You
it.
don't need it for the mirror box, dude.
Oh.
Because you don't need the virtual camera.
Okay. All right. Let's try that one more time. So, oops. Let's see if that works. Not really doing it. So we might just need to. We'll try one more time, and then if not,
The old-fashioned way.
we'll do it the old-fashioned way. So let's see. I tried switching it to Mirrorbox camera. It didn't work. So I got to say this Mirrorbox screen cap is not the best. So let's do this the old-fashioned way and point the. Here we go.
Make that full screen.
Yeah, I will. Okay. So anyway.
So I'll show you.
So this is the old-fashioned way of showing it, which is pointing a camera at our screen. But
So, for example, a game that I had in the simulator, for example, I can run it on here. Here you can see.
right.
Very nice.
So anyway, and then it's easy enough to install multiple games on there, and then you can. How do you get back to the menu?
I press the exit button, and then it will restart.
And then there's a bunch of settings in the MakeCode arcade that you can change, right? Like the sound settings and some of the other things. It is a little bit square, so on my 16:9 monitor, it has some black bars inside. Anyway, thank you, Isaac, for showing that. Let's get back to our next one. All right. Anyway, so anyway, what do you guys think? Interesting for kids?
Yeah, I really like the menu that puts everything together in one place. It's like they can build their own collection.
You're muted, or maybe
You can't hear
unmuted.
No, I can hear Ash.
Yep.
Oh, okay, hold on.
State. Okay, backstage.
So Isaac is back, but now
Welcome
I'm
back.
That's weird. Okay.
Yeah,
Yeah,
that's
that
it.
So
That
Yeah.
menu is awesome, where you put all the games
goes to
together.
show if you have a demo,
Yeah.
if you have a demo, it will never work. Hold on a minute. Okay. All right. Having three cameras open at once. Not the best situation. Not the best situation. So I'm sorry. What do you guys think? Does this seem like something that'd be interesting for kids? I mean, it's neat because at least it lets you transition to different languages if you want to.
Yeah.
Yeah,
Really nice piece.
yeah, and there's actually, if you want to, as we're going to do, you can also make it fancier and hook up an arcade joystick and arcade buttons.
Yeah, that's our goal. Our goal project is to take it from being a breadboard with cheap buttons to an arcade box with an arcade stick. The thing
An
about it,
arcade button.
yeah, and I think what's useful too is, I mean, it completely wants digital input, so you don't need to have an analog. I mean, you don't need to have an A to DC adapter, which Raspberry Pis don't. Now, what I'd like to see somebody find a way to port MakeCode Arcade to RP2040. I don't. Maybe that's a stretch. I don't know.
Yeah,
That would be cool with the Pico
because
system handheld.
Because I mean, you can't. Because I mean, AppRoot sells the Pi Gamer, which is its own microcontroller board that can run it. But the point is, well, if it could run on a Pico board.
Yeah, I mean,
True.
we have seen emulators run on it, so it's not out of the question. So speaking of
Speaking of which, it's made for microcontrollers too.
yeah, there's a lot of different things that can run MakeCode. So speaking of different things that can run different things, Les, you've now had a chance to try a bunch of different RP2040 boards. what do you like the best, and what surprised you so far?
That's a tough one, that. So I've played with lots of Pico-based boards, lots of RP2040 boards. The smallest one being the tiny 2040 from Pimoroni, which was a great little board. Little is the operative word here. It's tiny. It's about a third of the size of a full-size Pico. It gives you just enough in. There we go. It's like a thumbnail in size. There's nothing to it. It's fantastic for embedding into a project and sort of forgetting about it. I mean, it's about $12.
And our tiny, it's really easy to use the RGB LED with MicroPython. We figured out how.
It's good
fun. It was so hard to figure out.
And at the other end of the scale, well, we won't say the other end of the scale, we'll say an alternative. We have MakeCode Pico, which is my personal favorite, because it's just like a big playground of electronic components ready to go with a Pico in the center. Brilliant.
But what is cool is the feather Pico, because you can use any feather accessories, and we hooked it up to a Wi-Fi board, but it's not working really.
Isaac, you are reading my script. You're fantastic. Exactly. The Feather RP2040 from Adafruit is the best because, all right, we're losing some pins. That's not a big deal. But the form factor is fantastic. You can just plug it into all these feather wings and add on lots of great features, such as Wi-Fi.
We tried it with the Wi-Fi one, but we couldn't get the Bluetooth part of it to work. We couldn't update the firmware. So I was looking into fixing that.
Adafruit's got a guide out on that, how to do BLE with it.
Yeah, but they couldn't update the firmware to the firmware that works with the BLE.
We'll figure it out. But I want to hear what Les is talking about. So what have you, Les? What have you managed to do with the RP24? I know we put up our review of it, and you liked it a lot.
Yeah. I managed to connect it up to Wi-Fi. There's a guide on how to connect Pico to a ESP32 coprocessor from Adafruit, a Feather wing. But I've also got that to work with the Feather RP2040. And because the two just slot on top of each other, they're designed to fit that way, you've got a nice form factor, a tiny form factor ready to go. And I've picked up as well a Feather wing for RGB matrix. So what Ash and Abram have got behind them, I've got as well behind me, but it's in a box, not built. I have done some tests already with another board to show images with an RP2040, a Pico or a Feather RP2040. And that's one of my work in progress when I get a bit of time.
Yep. So right now we have the Airlift, which is the Wi-Fi one, with the Feather, and when I got it, I couldn't get the stackable headers, which I think is what you were talking about when you said it goes on nicely. I have to now they seem to have them back in stock. I wish Adafruit had some kind of a program where you could just buy stuff when it's in stock, and then they would like ship it to you once a week or something, like Amazon does with Prime. Because they're constantly running out of stock of stuff, and I want to go buy it, but I'm like, wait, should I wait for something else to come in stock? It's the RGB, the Matrix Matrix Feather wing is out of stock at the moment, or else I would get one. The interesting thing though is I don't think it does the resolution that I have here and Ash has behind her, which is yours looks like mine, which is I think 64 by 32. Right. And theirs I think only does up to 32 by 16 or something like that.
I'm not sure. I've got an M4 base board from Adafruit, and I can't remember what it's called now. Matrix Portal. There we go. Matrix Portal M4. That will do. I've got a 32 by 32 matrix, and I've got two of them, so I've got 64 by 32. So I managed to get two logos, Tom's Hardware logo and the PyCast logo, side by side the other week, and that worked really well. I haven't tried it with a Pico yet, though, but that's on my list of things to do.
Well, yeah, I mean that's gonna be awesome. I think that would be a great use case because there's just a lot of overhead in running the operating system to get it to do that. So I bet it would flicker less too. because it doesn't have to do anything else. So
Now, Ava, didn't you and Isaac put together a small video game on a little matrix board?
Yes, we did. We had one. We have to translate it, but we had one going on the Unicorn Hat HD, which is 16 by 16. So it's kind of been a project that I want to get it to going to the 64 by 32 over there, but it's a different aspect ratio. Or actually, what I want to get it to going for is I have a 64 by 64 panel. Also, so it's higher density, but I have to go through and recode the whole thing. And the one big problem with it is that we code the whole thing using the Pygamer library, the Pygame library. So that requires a screen, like a regular LCD screen, it seems, running X windows of some kind. So I to do things like keep the score and all of that. So I have to try and find a way to decouple it from that, and that has been holding up the progress, because I have to find another library to use to help me make a game that doesn't require an actual screen, so that I can have it just be on that. Although maybe there should be a screen to show the scoreboard. I don't know, but I remember we had a guest on a few months ago who was showing all these cool LED games that he had made. We would love to go and make some more.
Yeah,
LED
so
games.
we tried to make our own, but we took a break of it, though it was going to be a good thing, and we're making it our own menu.
Yeah, we also had to make a menu for it and stuff like that to get you through. Anyway, so that's about all the time that we have today. Thanks as always to everybody who tuned in. Sorry that we had somehow I scheduled this for Wednesday, so we had a smaller audience, because I think people who would have normally got the alert earlier didn't. Sorry, I think I put it up late at night and therefore picked the wrong day. But we are always here Tuesdays at 2:30 p.m. Eastern, 7:30 p.m. GMT. And next week, our special guest is going to be from How To. It's going to be Tyler. Is that correct? Ash?
It's going to be Zach. Zach's doing
Zach.
this.
It's going to be
It's
going to be Zach from How To. And the week after that, the 13th, we already have a guest lined up. It's going to be Spark Fun, which is going to be awesome. So anyway, you can always catch us here, or archivally, you can catch us on YouTube, Facebook, or an audio only format wherever you get your podcasts. Bye, everyone. Okay, hold on.